Is it streaming yet? I can't see anything. Okay. It's always a bit slower. All right, I'm going to try using that. Nice. Nice, nice, nice. Oop. Yes, I know. Thank you. Good morning. It's quite a nice day today. I guess you can. No, you can't really see behind me, but I can see behind me, and it's awesome. A great day to be stuck inside doing programming. Nah, I'll get out after this. Do some scope, then we do some fresh air, then we do some research papers in Com 1900, and then I think I might just go exercise for a couple of hours. Cecilia's going to put headphones on or something. Yeah, there are weird things going on with the website, so it's worth talking about because this is a website stream. If you ever try and get to the website, oh, it's an old version of it, using, so http colon slash, that's the website, HTTP, and you'll notice that it puts up the little security symbol. This is not secure, and it's like, yeah, well, of course. Why do we care that it's secure? We don't. But a lot of things are defaulting to HTTPS, which is a good idea in general. But if you try and go here with HTTPS, it will tell you that that's not safe because it's, well, just let me through. Oh, because I already set the override. Can I undo that override? Remove exception. Okay, so what you see when you go there is something like this. And that's because this website doesn't have a certificate, because certificates cost money and we don't need them. And maybe if we get more visitors, and then we'll be able to afford a certificate, but we don't have one yet. But you don't send any information to this website, so it doesn't matter at all. So it's complaining because you've tried to go to a secure site, but the site has no certificate. And you tried to go there by putting HTTPS. So if you don't try and go to HTTPS, you just try to go HTTP, you're totally fine and it doesn't complain. And there's no risk on this site, so there's not a problem with just adding an exception and continuing, and then the error goes away. The reason it's cropping up is because some of the places where I'm linking to this site are automatically adjusting the HTTP link into a HTTPS link. And then that's when you take it following that link, you get that complaint. So obviously I should try and get a certificate for it. As you can imagine, that the university's not really got the bandwidth to give certificates. And this is an external site to the university anyway, so probably have to go through something else. And then, like I said, it costs money, lots of other things to do. Rather than spending our time and energy on getting a certificate on this site, we're going to spend it on getting more material up for you. So that's probably the trouble you're having, I guess. Tabs 12, 13, 45. Wish.com. Let's get to the useful page. Scoop. Just give it another couple of minutes before we start up for real. Programming is exercise in a strange way. Your brain takes a lot of energy, and when you work it hard, you get really tired. But it's not really exercise. Your body still needs exercise as well. Summit 2 we'll talk about on the forums, and I can make a vid to talk about it, or maybe make a Zoom session to talk about it, but I won't do it here. It's a good idea though. Maybe we'll schedule a session just for chatting about assignment 2. Of course, you can always go to consultation times, which are Monday 2 to 3. Yeah, and any questions you have about assignments can be asked in the tutorials. Especially if it's the first assignment, which was marked by your tutor, so they'll be able to give you this initial answer. But also on the forum, so I can give you answers there if need be. The Friday stream, well, okay, one more question about the course before we start into the stream. There were just technical issues doing the handover between two tutors on Zoom. You've got to set who's going to be the host and who's not going to be the host, and we got that messed up when we tried to sort it out because we had to switch tutors because there was some prior arrangements. So straight up technical, couldn't get it to work, and that was a bummer. We think we've learned how to do it now, though. Well, we thought we'd learned before, but we think we've got all the edge cases sorted. Okay. Keep the noise down a little bit. Some entertainment in the background. Okay, let's get going on scope. I thought we might start with one of these Kahoots. And I'm torn on Kahoots. They're kind of fun, but they're kind of like a high school thing as well. But hey, why not just like have fun when you can? Play a live game. This is what we want to do. Which background? The person spying or Gura? Well, they're both cute. So this is one of these warm-up Kahoots. I love doing these where I ask you questions about the stuff we're about to talk about to get your brain in the mood for it and to find out who's already done the material and to help you see where you're at. So we're going to turn the friendly nickname generator on because someone had some problems with that a little while ago, and we'll fire this up. So I guess we got the, only I can hear the music, great. We've got the delay to deal with, so I put a longer timer on everything. Let's see if anyone joins. 287701. All right. And I get to see what the Stella GNU, that's a wonderful name for a programming one. GNU is not Unix. Emus and hawks and ducks and lemmings, and giraffes, camels. I much prefer these auto-generated names than letting you choose your own. All right. Captain Lemming. Yeah. Decisive sloth. Okay, ticking along, give it a bit longer. Yeah. Yeah. The boy, he loves his scooter, he goes back and forth on the deck. This is lockdown life at my house. All right, looks like, oh, no, another little, no tricks yet, no. As you can see, still got the handlebar. It's a skateboard with a handlebar, so you can start learning and then you take the handlebar off and off you go. Can you give formal parameters default values? In Java, no, you can't. That would be very useful, and other languages do allow it. It's like being able to combine declaration and initialization in the parameter slot. Makes perfect sense. If you can do declaration and initialization elsewhere, why can't you do it in the parameter slot? Well, a heap of languages said, yeah, that is a good idea, we'll allow it. I'm trying to think of ones you might know of that do that. I know for sure Ruby does it. I'm fairly sure JavaScript does it. I think Python does it. It's really hard to keep track. There are so many languages and so many possibilities. But I know Java doesn't yet. And because Java doesn't, that means processing doesn't, sorry. Yeah. Oh, we're still ticking in. We'll give it a couple more minutes. You can also hear, I presume, hear him bashing into the walls, which won't last much longer. They won't see out the lockdown. All right, there we go. We're settled. Let's go. Start. I'm interested to see how this goes with the lag. I've given 20 seconds on each question. Bit of code. How many variables are in this program? This is what we really want to start thinking about. What's a variable? Where are they created? That kind of thing. 20 seconds goes fast. Too fast. We only got 65 answers. You're going to have to go fast, guys. All right. I've learned a lesson. We need longer than 20 seconds, but we'll push on. To those of you on whichever the laggiest stream is, I apologize. All right, very good. Yes, 2 variables in that. That's fairly easy. You could see there were 2 with 2 names. But the next question, and so this is actually a scoreboard for who's got the best connection, right? Because the faster you get your data, the faster you can answer the question. The next question asks about declarations rather than just variables themselves. How many variable declarations are in the program? The 20 seconds includes the question time, I see. All right, they're moving faster this time. Hop on away to the music. Very good. 2. There's no magic there. You only get a variable when you get a variable declaration, right? It's the only way to create one. So those 2 numbers should be the same. Next question. Oh, let's see. Happy Wildcat. Horse. Space Elk still killing it. I made this one multi-select. I probably didn't mean to, so just select one. How many variable uses are in this program? That means I accidentally set, I must have messed this one up. Let's see, go, go, go. No, there's only one right answer, but I let you multi-select even though there's only one right answer. Okay. So yes, how many variable uses? 6. So there were only 2 variables and 2 variable declarations, but those variables were used in many different places. So you can have way more uses than you have declarations, way more uses than you have variables. All right, we wiped out Space Help. All right, different program. How many variables are in this one? It's a very similar program. It's got 2 extra lines on line 9 and line 10. And this one gets to the heart of what we're talking about this week. So I'm glad we got a breakdown there because X and Y, there were only 2 variable names. And so we could be tempted to think that there's only 2 variables. But what we're getting at with this scope material is that there could be more than one variable with the same name. So yes, X and Y were the only 2 names, but there were 2 different places for each. 2 different places where an X was created, 2 different places where a Y was created, and that meant there were 4 in total. And that's exactly the problem we're trying to solve with scope. What happens when there are not enough names? This one's multi-select, but I'm guessing there's only one answer to this one too. How many variable uses are in this program? None of those answers are right though. Oh no, yes they are. I counted wrong myself. There you go, 6. I added 2 extras that weren't there. So there were a couple of extra declarations and a couple of extra variables, but no extra variable uses, which is interesting. A variable use is just anytime you go looking up a variable name into the memory, and there were still only 6 places we did that. It was when we drew the ellipse, and then also twice each for when we incremented the variables. This is my favorite animal out of emu, elk, bison, mouse, and leopard. It's got to be emu. Emus are the best. All right, how many variable declarations are in this program? And we're back, and this is the same one again. So even if we got confused about how many variables there were, we shouldn't be confused about how many variable declarations, right? We know exactly what a declaration looks like, so we can just count them up. Very good, 4 of them. Anytime there's a type name and a variable name, that must be a variable declaration of some variety. Yeah, my apologies to the 20 seconds delay people. Yeah, I knew it couldn't possibly work out for everybody, but I figured it was worth a try. All right, so we're warmed up now though, right? And we get to see our podium. Jolly Yeti. That came out of nowhere. Smooth Leopard. And why is this so excited? Ah, thank God, the emu. Score. All right, well, good work, emu. I guess that either means you have an instinct for this or you pre-prepared, which is good. Obviously, it's better to pre-prepare for this material. Much easier to understand what's going on. Yeah, I got smashed on that last one. Okay. So are there any questions that came out of that we could talk about before I move into? That's part of the other reason to do these warm-up quizzes, to get some questions going in your brain that we might then be able to answer. Any names? Okay, let's go. I'm going to turn this darn music off. Ugh. So you can see I got another one. Oh, where'd you go? That's not what I wanted. That one. Another one we might try later, which only has one question in it, once we've warmed it up a bit more. Okay, scope. So like I said before, I've got to put a key point in this slide, these notes. That'd be better. We've made it to the point where we might have two totally separate variable names with the same name. In fact, we were there a long time ago. You could have done it any time. But it's necessary now that we have functions. Well, is it necessary? We'll talk about that later. But it certainly happens a heck of a lot. So I've given you an example program to show off what we mean. Let me fire this one up and show you why it makes sense for it to be the way it is. We'll talk a little bit about this function. Sorry, this method. So it's just a circle which is supposed to be a UFO and a shadow which is supposed to be the shadow of the UFO. And the idea is that because they're both being drawn across from each other, you probably can use a similar setup for both. They both need to know the same piece of information, which is how far along the sketch are we. So they both need to know an X position to know where to draw themselves. And because both of them need an X position, we give them both a parameter for X position. But that means the only sensible name for that parameter is X position. It's the same sensible name for both of them. Whether we called it X or X pos or X position, whatever we chose, we shouldn't make up a different one for the other one. And so all of a sudden, we've got two variable declarations in this program declaring the exact same variable name, the exact same name. We've got this declaration, because remember, any formal parameter in a function list is a declaration. And on line 20, we got another declaration, and they both declare xpos. And in fact, in this program, I thought I'd ramp it up a bit. So you also need to keep track of the global position that both of them are going to be using. So we call that xpos as well. And now all of a sudden, we've got three xposes running in the program. And that's not good, right? Because what I told you earlier on is that when you make a variable, it creates a slot in memory, and the name points to that slot in memory. Well, now there's a name, xpos, but which slot in memory does it point to? We can't know. Okay, so maybe there's three xpos names, probably. But how the heck can we tell one from the other? If you just write xpos in your program, how does the program know which xpos? I might have to shut the blinds. It's too distracting for me as well. Well, let's give that a go. Back on the scooter now. Oh, I think he was enjoying the attention. He's not happy at me now. All right. It's just, I apologize, but it is too distracting for me. Xpos, xpos, xpos. We've got xposes everywhere now. So I guess the real question is, when I write an xpos use, which variable am I even talking about? So we might make another example, because we do have an explanation of this example already in the notes, so we don't need another one. So maybe I'll make a simpler one that we can discuss as well, rather than just doing the exact same discussion again. Go watch that video if you haven't watched that video yet. It's good. So let's make two declarations that do an x and a y instead. And I'm just going to be brutal about it. I'm just going to redeclare variables for no good reason in this one. Whereas with that other example, there was a good reason for it. That was a program that made sense to have multiples, but this one won't. I'm just going to show you that you can just brutally do it any way you want. No, don't need to save. Okay, so there's my ellipse that's at position 0, 0, because that's what the x and y was started as. And maybe if I change those to something else. Then the circle comes out somewhere else, so be it. That's all good, not a problem, right? So this is a normal program. I can change the x and the y so that they do some kind of animation. And we might just carefully tell ourselves exactly what we've got in here. We've got a declaration on line 1, a declaration on line 2. So now two separate variable names. Then we've got a use on line 6, a use on line 7, two uses on line 12, and a use on line 13 and line 14. Fine. And we get a little circle that heads off down the side like that. Yeah. But what if I just did something strange like put the x, did a whole new declaration for x and y here inside the drawer? Would I be allowed? That seems strange. Yes, I am allowed. And the result of is that the program stops moving. So we can maybe guess at what the rules are just from the behavior of that program, but let's go through it. So first of all, yes, you are allowed to make new declarations of variables where old declarations of variables exist. There are some restrictions on that. For example, if I've just done an int x, it won't then let me do yet another int x, I don't think. Maybe it will. No, it won't let me. It's smart enough to know that there's absolutely no good reason to have an x there and then an x immediately after. But because of the way functions work, the processing has to allow an int x and an int y inside a function, even if there's already an int x and an int y outside the function. So it will allow that. And in fact, on a lot of scopes, not all of them, but on a lot of scopes, when you introduce a new scope, which we'll see exactly what I mean by that, then you can introduce a new variable. So another example where you introduced a new variable before without realizing it in an inner scope was when you did loops. They always looked like this. Let's just do 10 of these circles. We just did our loops like this. And if I just make these, this will make circles that go across from each other, I believe. Yeah, so now there's 10 circles 1 pixel apart. Maybe 1 pixel is not quite enough, so let's go to 100 plus 5 so they're a bit clearer. Plus equals, or equals plus. Let's go plus equals. Yeah, so now I've got a loop running multiple circles, and then, so each time I draw one circle, I'm actually not drawing one, I'm drawing 20, and across they go. But the point being here is this is yet another declaration. So we were already used to doing declarations inside scopes. Anytime you see a type and a variable name like that, it's a declaration. We're already used to the fact that the for loop gave us kind of a fresh place that we could declare new things, and we used it right here. And if you turn this into a while loop, you would have had a while loop where you probably created your own declaration. So the while loop version of this goes int I equals 0 and while, and that goes away, that goes away, and I plus equals 5 goes here, right? So again, to make the while loop work, you had to be allowed to put this extra declaration in here. And it would let you do that. Nice, not a problem. So maybe already we can start to believe that we have to be allowed to do this. I can talk more about exactly why we have to be allowed to do this. It's quite a deep topic. We don't go into it in full depth, but it's one of those things that's right down at the core of computer science. But now, once you would accept that you're allowed to do it, then you've got to deal with the consequences of being allowed to do it. So let's get rid of this one because I didn't need all that complication in this particular example. Okay, so back to one ellipse. Now this ellipse is still not moving. So we're going to fire up the debugger and have a look, I think. I might just fire it up without these. So hopefully you can use the online textbook to find the exact concept of scope. If you can't, then I've not written the textbook very well, and we can do better. Let me know exactly what you're confused about after having read all of it and watched all the slides, the videos. Okay. So if I fire up the debugger and put a breakpoint here, just want to show you that, oops, didn't work. Breakpoints never work on the size call. That's right, breakpoints don't work on size because that goes into the special place. Once I hit the breakpoint, I can see I've got an X and a Y declared in the debugger. And that's exactly what I expect because by the time I've gotten to this line, I've run through line 1 and 2, so I must have declared an X and a Y. And then from here on in, I've got uses of X and Y. This one will cause me to look in there and find a 0, but then it'll cause me to look in there and update it. Sorry, this one will cause me to look in and update it. This one will cause me to update it. This one will cause me to read it, read it, read it, read it. No magic there, right? And I can just step across and see each line and just see that there's still only an X and a Y. Some magic new variable called now turned up, which I guess is kind of cool. And I can't step anymore. Ah. Why can't I step anymore? Because once I hit draw, there was no other breakpoint. I pressed the wrong kind of step, I guess. Let me go back to doing step into, which I'm more used to, which I think is Mac Shift J. Yep. Nope, still went straight through. The debugger never does exactly what I expect. It's like a dark art debugging. Just put another breakpoint in here to force it to break again. So now I'm stepping, and it still didn't do the draw. Oh, because I put it on a comment line. Yeah, nice one, Matt. It's never going to get a breakpoint on a comment line because a comment line never executes. Yay, we broke again. So I really just wanted to show off that there's still only an X and a Y and an X and a Y and nothing else, right? So what does the debugger say when we rerun it with these two in there? We know that we get different behavior. Let's see if it can enlighten us in any way, shape, or form. Okay, so it's when we're stopped on line 6, we've just got an X and a Y. That's what we would expect, I suppose. Okay, now look, we've jumped into draw, and it's jumped past those two lines because I put the next breakout point down here. And look, it's created two new X's and Y's for me. And it's given them a slightly different name, this .x and this .y, which I guess is cool. So processing knows the difference between them. That's useful. That's a good clue. So first of all, we've now learned that, yes, you do get multiple X and Y's pointing at different slots in memory. That's exactly what the debugger is showing us. And that internally, processing somehow keeps them separately. We don't need to understand why it's called this one this .x and why it's called this one this .y, but it has given them separate names. And that's exactly how we need to think of it. we need to think of it as this x and y up here are somehow, maybe we'll call it x1 and y1, and this one down here are different ones, x2 and y2. Or the language people will normally use is that this x and this y are global, global x, global y, and these ones are local, local x, local y. Much easier to tell the difference. And we're calling these global. Anything that sits up here in the slots before we started writing any functions are always called globals because they're always available everywhere. Yes, so let's get to the reason why it's not moving around now that we've got them down here. So the reason it's not moving because we've got them down here is that when I use the x down here on line 14, processing has to decide which x I'm talking about. Am I talking about the local x or am I talking about the global x? And according to the scope rules, which tell you always go for the closest one, that's basically what scope rules say, go for the closest one, it will be talking about this x here, the local one. And when I ask about this y, it will be talking about the local y here. Cool? So that's fine. If I step that, that draws it at the center of the screen. And then the local x gets incremented and the local y gets incremented. Seems reasonable. But when we jump back around to the start of draw again, look what's happened to x and y. They went up to 401, but they now got reset back to 400 because we've rerun the lines 11 and 12. So the global x and y never got touched. They're now just sitting there kind of invisible. And it's only this local x and y are getting used and up incremented and reset. Used and incremented and reset. Used and incremented and reset, which means it'll never move. It's always being drawn at 400 by 400. So there's a, that's the rule we want to know about scope. I can't draw on this screen just now. That's okay. Scope means scope is a noun and kind of a verb. The biggest scope is, well, I can do it this way, I guess. The biggest scope is the global scope. It just includes the whole program. Everything's inside that global scope. And I think if I go, I can grab that from the clipboard. Yep, so there's my global scope. Now, inside that global scope, there are two more scopes. There is the setup scope and which looks like that, and the draw scope. Which looks like that. So these are the three different scopes in my program. Global scope down here, which covers everything. Setup scope, which covers just the setup function, and draw function, draw scope, which sets up just the draw. Now both of these setup and draw are called local scopes because they're smaller than the global scope. We basically break up between the global and all the others are called locals. It's relatively easy to see just from the text when a scope is probably coming into existence. It's the creation of a curly brace. Open curly brace and closed curly brace are, to a reasonable approximation, a creation of a scope. There's no open curly brace for the whole program, but yeah, there's just the global scope is just there. So the scoping rules are, anytime you see a use of a variable, go looking in the smallest enclosing scope for a declaration. So if I'm here in the draw function with this x, that's a use of x, and I want to know which declaration is it attached to. I go looking in the smallest enclosing scope for a declaration, and the smallest enclosing scope is obviously this draw one, and there's a declaration right there. So that's the x I'm talking about. Maybe I'm calling that x2, maybe I'm calling that local x, maybe I'm calling it this dot x, whatever I'm calling it, it's that x, the x on line 11. But over here in setup, where there's this use of x, programming will say, all right, processing will say, you're using X, which X are you interested in? It'll say, I'm going to look in the smallest enclosing scope for declaration, which is this one. And it says, I can't find one. There's no declaration there. So now I've got to look in the next enclosing scope. So the next enclosing scope is the global one, because setup is inside global, but setup is not inside draw. So you don't go looking in draw, you just go looking in the global. So we go out like I'm playing pass the parcel in reverse. You go outwards looking until you found the scope that does your declaration. And we find an X and a Y declaration in that scope. So that's the one we use. So when we're in setup, the X and Y we're using are the global X and Y, but when we're in draw, the X and Y we're using are the local X and Y. Cool? And we can take this one step further. If I go back to put that for loop back in, now in this case the I is a totally fresh variable name, so I don't have any confusion, but I do want to show you that if we go to a program like this one, if I go to a program like this one, then when I break up the scopes, these guys, we don't need them anymore. When I go to work out what the scopes are, ooh, junk everywhere. I'm going to still have the global scope. Looks like this one. I killed preview entirely. Global scope. And I still have the setup scope, which is inside the global scope. And I still have the draw scope, which is inside the global scope. But if I look inside draw, there's another scope for me to pull out, which is the loop scope. Okay, so I've tried to make these kind of in a shape like they're nesting, right? The global scope is the granddaddy of them all. Then its two children are the setup scope and the draw scope. And the draw scope has a child of its own, which is the for scope. So this one's got 1, 2, 3, 4 separate scopes I might have to look in. And I just go through each use and look in the smallest enclosing scope to find where it is. So when I use the I here, I look in the smallest enclosing scope for declaration, and I find the declaration right there. And I go, that's my I. Lucky, because there are no others. When I'm in the draw loop, when I'm in the X, when I look up this X here, I first look in the smallest enclosing scope, which is this one, and find no declaration of X. Then I look in the next enclosing scope and find a declaration of X, so that's the one I use. And I never go back up further to find this declaration of X. So you should realize the problem now. I'll ask, does anyone see the problem or a potential problem? Maybe you already have, and I just haven't been able to follow the chat. But the problem is, once I create this X and Y up here in the draw scope, this local X and Y, anytime I try to access X and Y, I'm going to get the local one. There is no way for me to say, I want the global one, please, because maybe I want to animate this again. Just not possible. Once you redeclare, the global variable is hidden, shadowed, something like that. Shadow is the language I normally use. The global X has been shadowed by a local X. And once you've done that, you can only access the local X. Okay. All right, so scope rules, that's them. That's the only rule you have to worry about for scope. What do we need to know scope? You need to know that curly braces generally bring them in. Opening curly brace, closing curly brace is the opening and closing of a scope. It's not precisely like that because, as you can see, this declaration here is just, it's outside the curly braces, but it's included. So it's really the keyword for that starts it. And back here with the loop, with the function as well, there's a curly brace to show you we're talking about scopes, but the scope includes the void and the draw. So curly braces generally are an indication that there's a new scope, and scopes nest inside each other. And when you're trying to work out which variable you're talking about, you go from the middle scope outwards until you find the one that has the declaration, and that's the declaration you use. So you've already seen here the consequences that can have. You can hide a global variable and mess up your application. And this works just as well if the declarations were here inside the function call. What I'm going to do is I'll move my ellipse drawing off somewhere else, right? It's not really an ellipse I'm drawing, it's a circle, so I'm going to make a void draw circle function, right? And this is pointless because processing has one, but well, okay, maybe I'll call this draw 10 circles. Or how many am I drawing there? 20. So this draws 20 circles, and it just takes all of this code and puts it in there, just for whatever reason. So now up here, I'd have to draw okay. So I've got a third x and y now, just for fun. I've got the global x and y. I've got a local x and y here in the draw function, which I've done with the declaration on line 11 and line 12. And I've also got local x and y's on the draw 20 circles function. They're not done in a separate declaration line like they were in draw. They're done in the parameter list, but that still counts as a declaration. So we're fine. And I've still got the scope for the I, the loop, so there's an I as well. But by the way function calls work, we know that the x and y I use here will get copied into the x and y that I use here. So even though I have created a new declaration, but because the way function calls work, whatever value was in this x will always be the one that appears in this x when we call it. So they're linked in that sense. And whatever value was in this y will always appear in this y once the function gets called. So we don't have that same shadowing problem because this isn't, well, I guess we do have the same shadowing problem, but it do have the same shadowing behavior, but it's not a problem because we're making sure that every time we're about to use this x, it gets reset to the value we want, thanks to the way function calls work. And if I were to kill these two off so that we got the behavior we wanted, we'd have a moving circle again, just fine. 10 moving circles, in fact. And that's because this x, now that we got rid of those two extra declarations, is the global x. And even though this x is the local x, before we ever get to line 19, the global x has been copied into the local x, and off we go. So it's the equivalent of actually doing this, which doesn't make any sense. The global x. We can't do this, right? But it's the equivalent of declaring it, but then immediately setting it to the global one, so we're good to go. So that gives us a clue, I guess, to why variable scope needs to exist and why it works well. It needs to exist for function calls. Way down deep in the core of computer science, in the lambda calculus that Church created, you must be able to create new variables without caring what they're called, and they must shadow the variables that are outside them, and you pass variables from a function call to a function declaration to link them up. So our programs just do exactly the same thing these days. So another one of these things where the consequences are fairly wide-ranging, but the rules are fairly simple. And so to start off with, and this is the way it should be with all learning of computer programming stuff, where you've got the simple rules giving complex consequences, is learn those rules, which were scopes nest inside each other. When you see use, you go looking for the declaration by going out through the scopes one by one, and just drill those into your head in the same way you might drill grammar rules or spelling into your head. And then start to trace and understand more complicated programs where the fact that you've internalized those rules means you can interpret what you're looking at. So that's why we've given this a whole week, even though it's just that tiny little rule, or those two tiny little rules, is that we want you to have a chance to internalize that rule so that the consequences of it in real programs is something you can intuit more than have to think very hard about. Okay, there's a lot more to talk about with globals and locals as well. But what I'm going to do is jump over and do that other Kahoot just to get our brain thinking on that line, and then I'll switch scope alternatives. It's just one question. I'll tell you what, I'm going to adjust it so the question takes longer. Edit. Oh no, then you can see the answer. What happened there? Well, okay, well, we're just going to do it with 20 seconds. Oh, unless I don't have multiple screens or any of that jazz, so I can't hide it from you. No, not that one. No, not that one. That one. They upgraded me to professional because we're all locked inside, and so you got 20 seconds. Go fast. You get new names because we're doing. I guess it takes a bit longer now. You can't just do really quick questions like you can with the active learning platform, which is a bummer, but that's all right. No, I'll just make you answer quick. Yeah, it's super laggy because no one's come in yet. So this is just going to be an exercise in getting our brains thinking. Ah, goodness me. If only I could trust you. I do trust you, but I shouldn't. Oh, mountain wombat, that's my favorite. Love mountain wombat. Wombats may be even better than emus. I went last year. I had something on down the south coast. I didn't feel like driving all the way down in one day, so I had to leave on a Friday afternoon. Left Friday afternoon, drove halfway down, and just found a field to camp in, and got woken up in the middle of the night by a wombat chomping, just about chomping on my ear, chomping on the grass right next to my ear. Frightening for about 5 seconds, and then awesome. Love a wombat. They're big. Oh God, no. You don't pet wild wombats. Which Celia wants to know if I pet it. No. No. It's best not to play Russian roulette with whatever diseases or whatever mood the wombat's in. Yeah, super cute. But they're grumpy. All right. So this question wants to know, why do we even have these rules? So I've got a couple of options. Never use the same variable name twice. Always use the last declared variable. Use the memory location directly instead of a variable name, or just get over it. There are no good alternatives. And I know I won't get many answers because you're all lagging, so I apologize. Well, we squeezed a few in. Good work. Yeah, I just stared at the wombat. So yes, get over it is the right thing to do. But it's really tempting. And this is a good idea for you guys. Just never use the same variable name twice. If you can avoid using the same variable name twice, it doesn't even come up as a problem. But unfortunately, like I said before, it's built into the core of computer science. There's no way to avoid it. I'm just going to explain to you why there's no way to avoid it. But so the advice for you, Don't use the same variable name twice if you can avoid it. That's why my UFO example was the one I've used in the video, because you could make up new variable names, xpos1, xpos2. That'd be fine. We wouldn't complain if you did that. But you're just arbitrarily giving strange names to things. And another one of the rules we tell you is use a logical name for something. And xpos is logical, and xpos1 is maybe logical. But the reason we still have to know these things, even if we lived in a world where we were just always using different variable names, is that the system can't always use different variable names. So when I wrote my void draw 20 circles function, there was only, I chose the variable name x and y. Now I can see my whole program, so maybe I could have chosen the variable name x2 and y2, and I wouldn't have had the problem. I'd have different variable names. But as you know, there are a pile of processing reference functions that also draw things that were written by someone a long time ago in a place a long way away that are now locked in our library. Circle, ellipse, line, point, all these need to know an x and a y position. And the person who wrote that function had to make a decision about what the variable name was going to be. And we don't know what they chose. We'll never know what they chose. In fact, if we look in the reference, it looks very likely that they chose x, y for those two. But we don't know that for sure because we haven't seen inside the code. Does that mean we can never use x and y because one of the library functions used it? That's where the problems come in. You're bringing in library code from all over the place and you can't possibly know what variable names they've used. And once code starts to get bigger, you can't possibly avoid all the variable names they've used as well. You're just going to have to get in the situation where you're allowed to use the same variable name in your program as a function from the library is used as well. And so processing internally would have to have this rule anyway to deal with that situation. And so that rule impacts you, so now you have to know it. Okay, I wanted to show a little bit more about the consequences of these different scope rules. We touched on it there with the global. But the way you can stomp on things with globals is something you're already aware of. So once we know about scope, we know that there are globals versus locals. And we might ask ourselves, what's better, having a local variable or a global variable? So for example, this does, no, that doesn't. In this example, there's no advantage to having a global variable, a local variable. Let me try and think of one where there is. Well, I'll just recreate the, I'm trying to work out whether I should recreate the problem that we see from processing or whether I should just use it internally. I think I'll try and recreate the problem that we see from processing. All right, let's say we wanted to draw, perfect. Instead of drawing these 10 circles moving along, we wanted the 10 circles, but we wanted a special one that was just in front of those 10 that was red. So what I might do is set these ones to draw 5 pixels further along and just draw one of my own that is in front of them, or first, and set it to red. That's how I do it. So I'm trying to set this ellipse to red, and then I want the rest of the ellipses to be drawn. Nope. What did I do wrong? Is it lowercase? What did I? Nope, I've forgotten how to do colors. Was programming in Java last night doing the Comp 1010 assignment. Oh, no, I can't. I don't have shortcuts for any of the colors in processing. That's right. Excuse me. Jumping between languages. No! Oh, because it's not set color in this language. It's just fill. You're screaming at me in the chat. 20 seconds delayed. And that's what I wanted to have happen. All of them went red instead of just the one went red. Okay, so what I'm going to do is recreate that situation here. Do I want to use the... No. So how much red is in my color has become a global up here. And what I'm really wanting to do is use that global variable here for filling, and then I'll use that global variable here for filling these. So it might be a bit more obvious now what's going on, because, well, you probably knew already because you've seen this problem yourself. Once I hit the red shade to 255, then this fill is going to use red shade of 255, but so is this fill. It's also going to use red shade of 255 because they're both accessing the same global. And what's happened is, even though these calls to ellipse are down here, don't seem related at all to the part where I set the red shade, it's a global. So once I set it, it was being accessed everywhere and it was affecting everyone. Yeah. So the alternative is to say, don't use a global, use a local. And then you'll just be affecting me locally. And it won't have any effect outside because this red shade is the global one, which hasn't been fiddled with. And this red shade is the local one, which has been fiddled with. And they came up black instead of white because that was 0. 255, 0, 0. So, hang on. Oh, because fill was white. Okay, so I messed with myself there. Hang on a sec. Fill was white, and then when I switched to calculating red, I could only get black. So I better just go to a white background. Let's just assume I wanted black circles on a white background instead of white circles on a black background, because otherwise it doesn't really work. Okay. So now that I've done that, the red is only affecting the one and not affecting the others because it's a whole separate, fresh local variable. So I showed you before how the local variables might break the animation, and that was a bad thing. That's precisely because animations require something global, because it requires something that's true in every single, that you can fiddle with in every single call to draw. But in many other things, globals break things and mess things up because it causes code in one section of your program to affect code in another section of your program in a way that's not so easy to track. That's not too bad here because lines 14 and lines 23 are only 9 lines apart. But if we had something in another tab, oh, why aren't you? So we might not have shown you this before, but you can move functions off into separate tabs and processing would deal with that for you, and that'll run just fine. You can call any function from another tab. Now the difference between the line 14 and the other line is not just lines, it's a whole separate file. And the fact that this is global is invisible to you when you're in this file, and so that could be a problem. And even worse than that, this could be off in a whole library somewhere that you don't even have access to the source code for. You might have loaded up a library. And if the library is accessing a global thing, then changes you make can affect things in the library. We make a big point of that because processing is built around a model where the things you change affect things in the library. That's exactly how fill works. You change the current fill and that affects how all the library calls happen afterwards. But in general in programming, we consider that action at a distance, which I think of as spooky action at a distance, because that's a phrase for a fancy thing. That action at a distance, where an action over here in your code affects things over here in your code a long way away, as a bad thing, because it makes it hard to understand broken code. It makes it hard to track down from the source of the problem to the solution to the problem. So we want to make you aware of the way that and this is what we called this is what we were calling intertwined in the algorithm section, because now this draw function is, well, if I take this away, sorry, the draw function is intertwined with the draw 20 circles functions. The two can't be understood separate from each other. And that makes it harder to understand our program. If you can make it so you can just think about one small part of your program and then only think about another part of your program, that's better. And that's another reason why scope rules are good, because having the scope rules lets me do this. It lets me say, I'm going to go for completely fresh variables and everything. I'm going to shadow all of the global variables that might have this name, and I'm going to only use variables that I've created that have this name, and I know for sure I'm not affecting anyone else's code. Or at least I know exactly in which ways I'm affecting other people's code. Okay, so that was all I wanted to talk about. Do we have any other questions? The actual code, I can't seem to produce the same result. There's the code. Is there any way to make red shade the only thing in fill? No, if you do that, so when you put one parameter in fill, you're telling fill this, I want to fill this as gray. When you put 3 parameters in fill, you're saying I want to fill this as RGB. And when you put 4 parameters in fill, you're saying I want to fill this as RGB alpha. So if you just put 1 parameter in, you're only ever going to get some shade of gray. You have to put 3 parameters in to get a color. Yes, so I can copy it down. There you go. Draw 20 circles. But it's better off back in the other tab anyway. For the size of programs we're writing, it doesn't make sense to me to break things out into separate tabs. For bigger programs, definitely. Code organization is a big deal, so you want to... so can we have red shade equals 255? It's a good question. You know, what I'm going to do is show you that, because it's a sideways thing on processing that I don't use much. But I do think it's a fun thing. What you're realizing is that instead of having a variable just for the red part of the color, it would be great to have a variable for all of the color. But I can't fit that in an int. But processing has got this super cool type called a color type, which doesn't exist in a lot of other languages, where you can put a whole color into one variable. And you do it using this built-in function called color. So I could do that here by saying color's not an integer, it's a red shade. But that means when I set it, I can't just set it to a number. I have to set it to all 3 of those numbers. And once I've done that, then I can just use it in here. Sorry, red shade. But that means I also need to change that to color. Okay, and I'm pretty sure that gives me what I want. Yep, that gives me what I want. So the magic here is in this special color type that processing got created. And in fact, they do some cool stuff with this. What they're actually doing is packing, and this is an advanced thing, the kind of thing you might talk about in what used to be called 202, and I've forgotten the new unit number for it, systems programming, where you take 3 integers and pack them into one integer, and then pretend the integer is not really an integer and call it a color. It's a cool trick. You can fit 3 small integers into one normal-sized integer if you pack them carefully and use some bit shifting to get them back out. It's a very old-fashioned trick. And I should say that that color red shade is not anywhere close to the number 255. It's a, if we looked it up as an integer, I think we'd find a very strange number. What happens if I print line it? I think it's just going to show me the packed integer to go with the, yep, minus 65,536 is the packed integer that pretends to be 3 integers, 255, 0, and 0. I don't know which tabs we want, but I can just put it all back on the same page so that we don't have to worry about tabs anymore. Yeah, exactly. So that's a good point. The reason that over here on line 2, red shade is calculating as 0 is because it's pulling up this red shade, which is defaulting to 0, which is the same as defaulting to, black. But that should be that now to make it really make sense, because I've switched to the color version. There's all kind of shenanigans going on under the hood there that we don't want to think too hard about, which is why I don't do examples with color, because it's a neat trick, but when you try and dig below it to see what's going on, which is exactly what we have to do in a proper course, where we're not just learning how to make pretty things, we're learning how to think like programmers. We've got to dig into it. Once you dig into the color, then you've got to touch on the bit shifting and why is an integer pretending to be a color, and what does this color function do? It just returns an integer, but I'm putting it in color on the code. Yes, that's exactly right. With the draw 20 circles, the reshade variables calling the global variables, and that has a value of 0. Correct. I'll go back to my int versions. So I probably should do something like, just to make that clearer, but of course the default for an integer is 0. Well, this one does use the local red shade. Why doesn't it on the other tab? Well, there is no local red shade. So it has to go looking for another one, and it finds the global red shade. So this fill affects all the 20 circles that get drawn here, so they get drawn black. This fill affects all the 20 circles drawn here. Now it might try and affect all of these 20 circles, it would, except the very first thing we do in that function is reset the fill using the global value. So if we trace the code here, the code would go set the fill to red, draw one ellipse, jump into the function, set the fill to black, draw 20 functions. And even though this line here, 16, looks exactly the same as this line here, 2, they do completely different things, because this line grabs the local red shade of 255, this line grabs the global red shade of 0. All right, things look like they've slowed down, although I've got to wait extra long because we're on a bit of a delay today. But thanks very much. Do let me know if you think the quizzes, whether they're Kahoots or something else, work for this. I might kind of do some more in the future. Get the timing a bit longer though, to deal with the lag that seems to build and build and build as these things go on, but that's fine. And otherwise, I shall see you all next week, I suppose. Thanks.